Good morning, Year 11. I'm here just to give you a quick recap of everything that you learned about the sine and cosine graphs in Term 1, Week 10. As you can see, in front of you is the sine graph, and there are a couple of periods of the sine graph, as you can see, all the way along. Just a reminder, sine graph goes from negative infinity to positive infinity. Let's look at the key features of the sine graph. This is currently in radians, so if we just remind ourselves that 3.14 is pi, so therefore 6.28 is 2 pi. The sine graph begins at 0, 0, goes up to a maximum point of maximum amplitude of 1, and that's at pi upon 2, comes all the way down through pi, then a minimum point at 3 pi upon 2, and then back up to one full period at 2 pi. Now we had a look at transforming this, so what I'm going to do is I'm going to alter the amplitude to 2. Okay, so you can now see that everything has stayed the same. It's just the maximum point is now at 2 and the minimum point is now at minus 2. But the period has not altered because we only changed the value of a. This is currently the graph of y equals 2 sine x. Now let's have a look at changing the value of d. As I alter the value of d, as I increase it, that equilibrium position, which is currently the x-axis, moves up. And the whole graph moves up. So you can see that's currently a value of d equals 3. The points where it cuts the new equilibrium position are exactly the same. And I did say to you when you were sketching, sketch from that equilibrium position. I put it on as a dotted line on my example. And look, what we can do is just draw the sine graph from the equilibrium position, assuming it starts here, goes up pi upon 2, down to pi, minimum of 3 pi upon 2, and then back up to 2 pi. Now let's have a look at altering the value of c. C changes the horizontal position. So as I go to the left, that's our horizontal shift to the left. And of course, I can have a horizontal shift to the right. And we talked about how we would take the normal key features of sine and we would just add or subtract those key positions to get the new positions when we were sketching. Let's have a look at cosine now. Now let's have a look at the cosine graph. So it begins at 1 with the amplitude. So it starts at the amplitude and then it comes down through 0 at pi upon 2, has a minimum amplitude at -1. Obviously here I'm looking at -1 at pi. Remember that's 3.14. Then comes back up through 3 pi upon 2 and then hits the maximum amplitude at 2 pi. Its period is 2 pi, and let's have a look at what happens when we alter that amplitude. So let's go up to 3, for example. That's now the graph of y equals 3 cos x. We also know that I can shift it. Let's go down with this one. And we talked about how to change the equilibrium position and just to continually sketch as if the equilibrium position is your x-axis. Then we had a look at the horizontal position and we looked at, we go back to 0, 0, let's move that amplitude back down to 1. Then we looked at the horizontal shift. And of course, it moves left, it can move right. I've just moved it right, apologies, and it can move left. And to sketch that, you just look at the key positions and either add or subtract them from their key positions, find the new positions to then sketch. Just if you're wondering about the graph of tan x, all you need to know is the key features of the graph tan x, and the only key features of that graph are the asymptotes. Let me show you. And so the tan x is formed by lots of these lines that go from pretty much, let's look at the range of this graph, it goes down to negative infinity up to positive infinity, but we know that at the key points, the first one is pi upon 2 or 90 degrees, there is an undefined angle. We cannot define that. And shown on the graph is an asymptote. And we've looked at asymptotes earlier on in Unit 1, but we usually denote that as a dotted line on the graph. This graph doesn't have the dotted line. But as I roll that unit circle along for one period of tan is still 2 pi. You can see here that at 2 pi there it's 6.28. It cuts through at 0. Okay, so on y it cuts through at 0, and we understand that at 2 pi, tan of 2 pi is 0. The main thing here is you will not be asked to transform the graph of y equals tan x. You only need to understand cos and sin x. All right, that gives you a quick refresher.